Welcome to Kenton's videos. Enjoy the video.
You will assemble the core, an Esp32, a microphone, and a speaker. This is the audio path. Flash the ESP-IDF or Arduino core now so you can compile. Once done, configure I2's pins and power rails because correct voltage prevents noise and damage. You should test serial connectivity and upload a simple blink and audio loopback. This verifies USB, drivers, and mic wiring. Make sure to note sample rates and bit depth for later, since they determine latency and recognition quality. Now you process audio and detect commands. Begin by capturing PCM from I2s with the sample rate your speech model expects. Mismatches break recognition. Next, apply DC removal, automatic gain control, and a bandpass filter to reduce noise. This improves accuracy. Once preprocessing runs, feed frames to a voice activity detector and a lightweight wake word engine so you only stream when needed. Then implement a circular buffer and a network client to send, or finish by wiring the recognition output to behavior. Either run an on-device model or send audio to a cloud ASR and NLP pipeline. Pick based on latency, privacy, and cost. Once text arrives, parse intents and map them to handlers that control GPO, motors, or APIs. Provide user feedback with short TTS responses or LED cues so users know state. Test extensively with different accents and noise. If things fail, capture and inspect raw recorded audio. This reveals mic, gain, or preprocessing errors quickly.
Thanks for watching. Consider subscribing if we helped you.